SwayamPrabha. Digital India. Educated India.
Hello, good morning everyone. So, we are discussing the various methods for idea generation as a first step towards the concept generation. We discussed one intuitive method yesterday and then briefly discussed about the second method also. The first method was brainstorming, which is very commonly used in generating new ideas or to get large number of ideas to solve a problem. And the another method we discussed was 635. So, I briefly explained the method by which 635 is implemented. So, we have 6 people sitting around a table and then each one will be given a A4 sheet for recording their ideas, and they will be asked to write down 3 ideas, write down or sketch or whatever way they want to express the idea, and they will be given a fixed time to do this stage. So, each member sketches 3 ideas for the primary product function, and after t minutes members pass their ideas to the person on their right, and for the next t minutes members modify the ideas on the sheet with the option of adding new ideas, and passing the sheet continues until a member's original sheet returns, the round ends. So, that is the way how the first round goes. So, at the end of the first round the first person gets his own sheet back, and then he will see that the first 3 ideas whatever he suggested, that has gone lot of modification and the new ideas have come in the sheet. So, at the end of this first round each sheet will be having 10 to 15 ideas to solve a problem. And then after some discussion, so there will be some discussion and then the round continues. So, they will go for another 5 rounds and finally they process all the ideas and then summarize the ideas. So, that is the way how the 635 works. So, just to give you a brief idea how these rounds will look like or how the people will start expressing their ideas in the sheet, we will take a very simple example and then see for some problems how the ideas can be generated and how this can be explained in the sheet. So, let us take the example of the tea maker. Again in one of the earlier classes I mentioned about the functional decomposition of a tea maker, and then there we found different functions needed in the product. So, the product requires many functions, sub functions are there in the product. So, you can take one sub function and then see what kind of ideas can be developed for that particular function. So, this actually shows the black box approach for the decomposition, and these are the inputs and these are the outputs. Okay. So, cold water, tea leaves electricity, hot tea waste leaves waste energy. So, you should take this as the input and outputs, and then you will be able to see that there are different requirements in the product. So, dispense correct amounts of tea and water, that can be a function needed. So, you need to have one function will be dispense water, one function may be dispense tea. So, this need to be in a proper proportion. So, we need to dispense correct amounts of tea and water. So, these 2 functions, how can we actually get a concept for doing that, or provide the right conditions for brewing, decide the right time to separate tea leaves from water. So, there are different requirements. So, we can say dispensing water and leaves is a function, heating water is a function, combining tea and water is another function needed in the product. So, these are the functions that can be identified in the tea maker. Of course, there are many other functions needed, but then we are just trying to take out these functions and then see how we can develop concepts using 635 method. So, look at this dispense tea. So, you want to dispense a fixed amount of tea leaves to make the tea. So, depending on the number of tea required, you need to have a fixed amount of tea leaves to be dispensed. So, what are the ideas that we can have in order to do this? So, if you give this to a person in the 635 method and ask me to sketch the ideas, then he can actually give many ideas like this. So, one is this a constant volume gravity feed, that is the name what he wants to give for this. So, he is actually explaining that there will be a tea hopper in which the tea will be stored, and then you can have something kind of a slide gauge. So, each time you slide it once, then you will be getting a fixed amount of tea. So, that speed at which you want to slide and what is the stroke length, that can be decided, and based on that you will see a fixed amount of tea falling into the container. So, that is one method to get the tea dispensed for a fixed amount of tea dispensed. So, another method could be a constant volume screw feed. So, now assume that there is this tea hopper storing the tea leaves, and you have a kind of a screw feed and a motor and a screw, and then depending on the number of rotations that you make using the motor, you will get a fixed amount of tea leaves coming out here. That can be another idea to solve this problem. So, if you make 2 or 3 depending on the number of rotation the motor makes, you will get the amount of tea. So, you can actually control it also. So, this is actually an idea compared, this also a possibility, this also a possibility, and which one you want to choose again depends on so many other factors. So, compared to the brainstorming method you will try to explain, okay, you can use a screw feed or you can use a gravity feed, but here it is much more clearer. Okay, what do you actually mean by gravity feed, what actually mean by the screw feed is explained using a sketch. And another one method can be a piston method. Okay, you can have a piston, a cylinder piston kind of arrangement, and then one stroke of the piston gives a particular quantity of tea leaves. So, that is the another method. It is a kind of gravity feed, but in this case it is not only the gravity, you are actually using a push stroke of the piston to get it out. So, that is the third method suggested. So, this is the way how the 635 will proceed, and then you pass this to the next person. He will look at this and he will get some idea, okay, oh, you have this piston method, gravity and screw feed, I can also think of some other method, and then he will also come up with some methods to add. So, keep on like this, it keeps on adding in the paper. So, more and more ideas will come. So, that is the way how it will proceed. And another example and another function, suppose it is dispense water. So, dispense tea is a function, dispense water is a function. Again you want to dispense a fixed quantity of water for making tea. So, what are the ways in which you can do? So, you can actually do a gravity feed, as you can see here, something similar to this gravity tea, but tea dispensing. So, here is a gravity feed and a water container and a valve. So, you can actually control the valve and then get the flow. It is a very common way of doing it. Another method is like this, you can have a controller, an inlet valve, inlet and a valve, a controller. The controller will look at the water level, and then based on the control input, it will just pump the water out. So, you will be getting the water out from the container using a electronic control. That is the one idea. Here it is again using a pump. So, you can just use a motor and a pump, very conventional way. So, you use the pump to get the water out from the container. So, you can run the motor pump for a particular duration, you will get the water coming out. Another one is an air pressure type. So, you can actually have an air pressure. So, this is a bellows. So, you actually apply some force here to move the bellow, then you will be getting the pressure, air will be pressurized, and that will actually pump the water out. So, that is the another method. And another one is a steam pressure. Okay, instead of having a manual pressure application, you can apply a steam, and that will actually pressurize the water inside, and then the water will come out. That is another way of looking at it. So, which one is suitable, which one is feasible, we do not worry about whether that is a highly difficult or very easy, how much complexity it will bring, all those things are not considered here. You write whatever the idea you feel it is good. So, whatever you think can be used, you please you keep adding it. So, you will get a lot of ideas like this. So, another function here, heating water. Suppose you want to heat water is a function. So, you can actually have brainstorming or 635 method idea generation sessions for individual functions. So, each function you can take and then do a idea generation session, and then you can get ideas. So, here heating water. So, you can use a heating coil. So, water will pass through the pipe, and then you can have a heating coil wound over it, then you will get and heating this you will get hot water. Another one is the conventional conduction mechanism. You have the heating coil at the bottom of the container, and then you will be using that to heat the water. The third one is an immersion coil. So, you can actually immerse the heating coil into the water and then heat it, or you can have a heater outside the container. So, you can keep it outside the container, and the heat this heat will be used to heat the whole container, and the water will get heated up, and then you can heat the water. So, these are the ideas. Of course, you can have many more ideas like this. So, you start with some ideas and then keep moving the paper to the next person, and then keep on adding ideas. So, another function is combine tea and water. So, you can combine this, you need to have fixed amount of tea and fixed amount of water, and then water is heated. Now, you need to mix this tea and water. So, how do we do this? So, we can actually have different ways of doing this. So, one is that add tea to the water. So, you have the water boiling, a fixed amount of water is taken, and then it is boiling, and then you add the tea powder directly like this. Or you can have tea straight to water. So, instead of using a sieve like this, you can insert directly add, or you can add water and tea together. So, you can have fixed amount of water coming from the water dispenser, hot water dispenser, and then fixed amount of tea coming from the tea dispenser. Both can be added into a container, you will get that. That also is a way of mixing. Or you can have water passing through the water and hot water coming, and through a tea container or a tea sieve, and you get the tea here. And here here it is hot water bypass the duct. So, you can have one pass for the hot water like this, one small quantity of water passing through the tea sieve, then you will get tea also. So, here you can actually control the amount of water passing through this, you will be getting a you can have better control on the quality of the tea. So, these are the ways in which you can think of getting the combining tea and water. So, this is how we actually do the 635 method of idea generation. So, the advantage here is that you can have a much better, much more clarity on what is the idea that you are proposing. You can sketch it, you can explain it the way you would like to explain, and write down all the details. So, the person who is seeing it will get better idea, better understanding of what you are proposing, and you will be able to take it forward. So, that is the 635 method. So, the first one was brainstorming, where you it is more vocal than graphical or creating sketches. Here it is more of creating sketches and then limited interactions. So, these are the two methods. Now, this also has got some limitation, because you do not have you cannot really explain the idea to the other person. He may understand it based on the sketches and whatever you mentioned. Probably you don't have enough opportunity to explain this to the other person. So, that is one limitation here compared to the brainstorming. So, to avoid this issue, people have come up with a slightly different method, which we call it as the gallery method. So, the gallery method is a kind of combination of both brainstorming and 635. So, here what we do, we will ask every individual to sketch his ideas and present it to the group. So, in this step, idea generation step, for 15 minutes the individual members create solutions intuitively and without prejudice, using sketches if necessary. So, they will be given, instead of giving an A4 sheet and asking them to sit around a table, each one will be given a big sheet, kind of a poster sheet, and ask them to sketch their ideas and explain it the same way what we do in the 635 method in the first stage. So, everyone will be given 15 minutes to sketch their ideas and whatever they want to write down and explain, all those things can be done in the on the sheet. And then what they do, this step is known as the association step. The ideas generated are hung on the wall and 15 minutes are given for identification of complementary and improved proposals through negation and reappraisal. So, what will happen, you all the team members will be preparing the sketches and they will hang it on the wall, and then they will go to each other and then discuss what is the idea that they mentioned and what are the pros and cons and what are the things they want to explain. So, they will explain, oh, this is my idea, this is how it works, and the other person can actually tell, oh, this can actually be modified, there can be a different way of doing it. So, that way they will be able to improve the ideas in the association step. So, this is to some extent a combination of the 635 and the brainstorming. So, for some time there will be some brainstorming happening after the initial step of idea generation, and this association step will help everyone to improve their ideas based on the feedback they receive from the individuals, and again they will go back and then redo the ideas and get more ideas. So, that is the idea generation step 2. The ideas and insights are further developed based on the association step, and this will continue for 2 or 3 rounds, and then they will stop and then they will sit together and consolidate all those ideas generated and then see how to take it forward. So, that is known as the gallery methods. The selection step, all generated ideas are reviewed, classified and if necessary finalized. Promising solutions are then selected. So, based on the first level of idea generation, they will sit together, work, look at all the ideas generated and then see what are the promising solutions and then decide to take it forward. So, that is basically known as the gallery method of idea generation. So, these are the 3 intuitive methods. So, the first method is brainstorming method, the second one is 635 and the third one is the gallery method. So, you can use any one or all these methods to generate ideas. So, the more the ideas, the better the final solution, that is the basic premise. So, you can have any number of idea generation sessions and any number of times you would like to do it, and any method you can adopt and try to see how you can actually improve the total number of ideas generated for a particular problem. So, that is the first stage in the concept generation or concept development. Now, you need to take it forward to the next level of finding out the concepts. As I mentioned, the ideas need to be converted to more concrete concepts. So, that is the stage where everyone will sit together and then convert these ideas into concepts. The concepts will be more concrete way of representing the solution that can be used for solving the problem. Okay, so, these are the 3 intuitive methods we discussed, and as I mentioned, during any of these idea generation sessions, you need to ask some questions to ensure that the idea keeps flowing. And so, these are some of the tips that you can use, okay, put to other users. So, how to have other applications, a particular problem or a solution. So, new ways to use, other users if modified, other places to use and other people to reach. So, these are the questions that you can ask, okay, can we use it in some other ways, or is there any other method which actually uses the same principle? Is there any other areas where this principle is being used? Are there any people who are using this to solve a problem? So, these kind of questions are the one which the leader should ask the team, so that they can actually keep the momentum. Similarly, adapt, how to adapt something existing. Okay, is there any way to adapt the existing methods and modify the existing methods? Can we give a new twist to this, or can we change the meaning, color, motion, order, taste, form or shape to suit a particular requirement? And magnify, can we expand things, can we add something, can we increase the time of application, or can we have more frequency of using this? So, this kind of questions in the magnify category. And then minify, basically the other side, okay, you can you reduce something, can you reduce the time, can you reduce the frequency, can you miniaturize, can you lower the temperature, or can you lower the weight. So, these kind of questions you can ask to. Okay, similarly reverse, combine something, substitute something, rearrange, eliminate. So, these are the key questions the team leader should ask, or the team members also can actually keep asking these kind of questions to themselves, so that they will be able to come up with new ideas. The reason why we are asking these questions is to keep the thinking in different directions. So, we want the participants to think differently and in different directions. That is why we keep asking these questions. That will actually trigger the ideas, and then that may lead to more good ideas coming out. So, the leader should have the ability to ask questions and then trigger the participants to come up with new ideas. Okay, that is the importance in the intuitive method of idea generation. Okay, so let us discuss the logical method here. So, the last three methods that we discussed, they are the intuitive methods, where the intuition of the participants plays the major role in getting solution. But in the logical methods, we have a logic in coming with a solution. It is not based on the intuition, but it is based on some logic. So, if there is a problem, then this could be the solution because of so and so reasons. That is basically a logical based idea generation. So, this was proposed by a Russian genius. His name is Heinrich Althusser. He was the one who actually systematized the invention. He said the invention can be done in a systematic way. So, that was his proposal. If you want to invent something, there is a way to do this. So, you go in that you take those steps, then you will be able to make inventions. So, that is the proposal he made. And this is known as theory of inventive problem solving, or TIPS in English. So, we call it as TIPS. So, TRIZ was the Russian acronym. So, he was a Russian scientist. So, he coined this terminology in Russian language, and the English conversion is theory of inventive problem solving. So, how can we solve problem using inventive method, and what is the theory for that? So, he proposed a theory of problem solving. So, finally, he said that okay, any invention can be done in a systematic way. So, normally we think that invention is not a systematic process, you keep on searching and you will find a solution. But he says no, do not do that way. There is a systematic way of approaching the problem and you can solve it. So, that is the theory of inventive problem solving. So, in the conventional way, suppose you want to solve a problem and you do not know where the solution lies, you keep on searching for the solution. Suppose this is the timeline, and this is the space where actually you need to search for solutions, and your problem solution may be somewhere here, it may be lying somewhere here. Okay. So, you keep on searching all these space, and then you keep on searching, and finally you reach here, oh okay, and then you will be able to get the solution. So, probably it will take maybe 2 years or 3 years to reach the solution, because that is where actually the solution, you do not know the solution where it is, you keep on searching all the space and then you find it out. But Althusser said you do not need to do this, you tell me what is your problem, I will tell you where will be the solution space or what will be the solution space. You go there and search only, you do not need to search all over the space to get the solution. You go to that particular location where the solution can be found, and then you search for the solution, you will find it. For example, now he is saying this is the, suppose this is the way normally we do the invention. He says that you tell me the problem, I will tell you okay, if this is the problem, your solution will be lying somewhere here. So, this is the only place where you can find the solution. So, that you can actually jump directly and then search for it, you will be able to get the solution in a much shorter period of time. So, this is the proposal he made, that is the essence of the TIPS methodology, where he says that if you have a problem, I will convert that problem into a systematic or a standard problem. Your problem will be converted into a standard or a generalized problem, and then I will tell you okay, where actually you can find solution, you go there and find a solution. So, that is what actually he proposed. And how did he come up this solution or this methodology? Basically he looked at the patent available in the all over the world. So, this person he looked at patents. So, all of you know that a patent is a document that you can see or when you do an invention, you file a patent application and then the patent authority will give you a patent saying that okay, you have done this invention and these are the details of the invention, you have the right to use it. That is a patent in general. And all this patent information will be available in public domain, so that you can search for the details. So, whenever you have you want to, or when you see want to know something about, you can actually search for the patent, and you will see people have tried to solve it in different ways and each one how they solve the problem. Now, this person he actually looked at all around 400,000 patents. He searched all the patents available in the world, because these are publicly available data. So, he searched all the patents and then each patent he tried to analyze what the inventor is trying to do. So, he was trying to solve a problem, and then he found that every design problem they were trying to address kind of a design contradictions. So, all the patents, because you want to improve something, for example you want to reduce the weight of something. Okay, you want to reduce the weight of something, that is your requirement. But when you try to reduce the weight, what will happen? The strength will also come down. So, the strength also will come down, which you do not like. You do not want the strength to come down, you want the strength to remain same, or you want the strength also to go up. But this is a contradiction. So, it is not possible to reduce the weight and then have the same strength. So, that is a contradiction in the design. Now, somebody will try to come up with a method to solve it, then he will get a patent and he will say okay, this is the method by which I try to reduce the weight and then still maintain the strength. Like this he tried to study all the patents, and he found that every patent is basically a solution to a contradiction. So, that was his first understanding. So, it is a contradiction in the design space. So, everyone is trying to solve a contradiction existing, okay, solve the contradiction, that is the first thing he understood. So, there is a contradiction in all the patent, whatever patent he is tried to understand, he found that there is a contradiction between two parameters in the design. So, for example like strength and weight, okay, that is the way, or the pressure to applied and the force to be used, things like that. And he found that all these contradictions can actually be and looking at all these contradictions, we found that there are only very few parameters which are contradicting, or all those 400,000 patents he tried to understand, he found that the contradiction can be generalized into few parameters only, and he realized that there are only 39 engineering parameters that contradict any design you take, or all the designs that is existing in the current world or the current patents are available. He found that there are only 39 engineering parameters that can contradict, or any design problem can be considered as a contradiction between only 39 engineering parameters. That was the first realization he had. And then again he tried to understand, okay, if there is a contradiction between one parameter and another parameter, what is the way they tried to solve it. And then he realized that there are only 40 engineering principles that can be used to solve all the contradictions existing in the world. That is, all those patents what are the 400,000 patent available, they used only 40 principles to solve a problem, or all the principles they used to solve the contradictions can be brought down to 40 engineering principles. And then using this he said, now you tell me your design problem, I will tell what are the contradictions existing in that design problem, and I can tell you if these are the contradictions, then I can tell you which principle can be used out of these 40, which principle can be used for solving the problem. Okay. So, that is the TIPS methodology, theory of inventive problem solving. So, it says that if you have a design problem or any problem you are trying to solve, I can convert that into a contradiction problem between two parameters, two engineering parameters. So, initially you may not you may not see that as a parameter, but based on the TIPS terminology, I can find out the contradicting parameters, and if I know the contradicting parameters, I can tell you which principle to use for solving it. So that you do not need to search anywhere else, you can only solve this problem through this principle only, and if you are not able to solve this through this principle, there is a very high chance that you will not be able to solve it. Okay. That was the principle of that was the TRIZ methodology proposed by Altshuller. So, let us briefly go through the process of TRIZ and see what are the parameters and what are the design principles that can be used. Okay, so, this I am leaving it as a self study topic for the time being, but I will just briefly tell you, but you need to go through read about it, and then there are a lot of literature available. You need to do some kind of self study to understand it in a much better way. Okay, this one I already told you, the TRIZ will take you to the solution space very fast. Okay, and he studied around 400,000 patents. Okay, so he found that there are only 1500 contradictions existing. So that is the contradiction, and these contradictions can be converted to parameters. So there can be only 39 parameters that will contradict, but total contradictions can be 1500, and then you find the parameter out of this 1500, what kind of parameters are involved, and found that there are only 39 parameters involved. Okay. And recognition that technical system evolved towards the increase of ideality by overcoming contradictions, mostly with minimal introduction of resources. That is the recognition he had. So very minimal resources can be used to overcome the contradictions. Okay. So the methodology is understand the problem as a system, make an image of the ideal solution first, and then solve contradiction. So you solve the contradiction by idealizing using the parameters and then solve the contradictions. And this is not a just a theory. So there are a lot of industries using this methodology, TRIZ methodology, to solve their problem. So if you take any major companies like Procter and Gamble, Boeing, Samsung, etc., there are so many other companies which actually use the TRIZ methodology to solve the problem. One of the very interesting one is the Boeing case study. So they had a very big design problem in the Boeing 767. So they were trying to solve a design problem in Boeing 767, and they actually spent 2-3 years in trying to solve it, and they could not really reach the solution space. And when this by that time when the TRIZ was introduced, they tried to apply the TRIZ principles, and this 3-year problem they could actually solve in 5 days. So that is actually a case study from Boeing. It says that they could actually solve the problem which was already they were working on it for 3 years, but then when they applied the TRIZ methodology, they could actually solve it in 5 days. The reason is that they were actually searching all over the place for the solution, but TRIZ said, okay, if this is the problem, you can actually find solution only in this particular space. So you go to that space and then search for the solution, you will find it. So that is why they could actually solve the problem, and they actually saved around $12 million in by solving this problem using TRIZ methodology. Okay, so what is TRIZ? Okay, let me go to the details. So the essence of problem, technical contradiction. So TRIZ says that the technical contradiction is the most important thing that is need to be understood in any design problem. What is the contradiction that you have? And then they identified that there are only 39 parameters of systems and has provided a matrix of 39 by 39. So he said or he identified there are only 39 parameters. Now you can actually create a matrix of the 39 parameters. That is, you have a parameter, so you want to improve this parameter. Okay, so for example, you want to improve the strength. Okay, you want to improve the strength of something, and then you see that this is something which actually goes against your wishes. So you say that, okay, I have this weight, the weight of the object. So the weight of the object is going against it. That means you have a contradiction between the strength and all these 39 parameters, they have this contradiction. I mean you can find out the contradiction between parameters, not necessary that every parameter will be having a contradiction with the other, but there can be parameters which contradict when you try to improve this. Suppose this is the improving parameter and this is the one which actually going against that parameter. Now this is the 39 by 39 matrix. Now we want to know if there is a contradiction between strength and the weight, and I am trying to improve the strength and the weight is actually going against my requirement, what kind of solution can be used to solve this. So that is what we need to know now. Then if we can actually have that kind of a solution can be identified, and then we will be able to get the solution space very easily. So that is the 39 by 39 matrix that we can have between the contradicting parameters. Now by surveying a huge number of patents, he found that there are only 39 and there are principle of invention to be used, and he found that there are only 40 principles available. There are only 40 principles that can be used for solving the contradictions. Any contradiction you will be able to solve by any of these 40 principles. Not all 40 need to be used, but there may be 3 or 4 principles that can be used to solve the problem. Okay. So that is the 40 design principles. Now out of these 40, there may be only 4 or 5 which are very commonly used to solve the contradictions. So you list those principles into that matrix. So whenever we have that 39 by 39 matrix, between the two parameters the contradiction is existing, you identify the principles which can be used to solve it, and then you prepared a 40 by 40 design contradiction matrix with the design principles that becomes the basis for all the problem solving using tips. So you have the 39 parameters, 40 principles and a contradiction matrix explaining what principle to be used to solve a contradiction. So that is the TRIZ. Okay, accumulation of this analysis revealed that in each of the 39 types of problems. So which principles are most used in each of the 39 parameters. So he identified all those parameters, all those principles, and then listed it in the matrix, saying that if you have a contradiction between this parameter and this parameter, use the principles 6, 8 or 10, like that he listed. And now whenever you have a design problem, you can just identify the parameters and then see which principle can be used, and then start using that principle to solve the problem. So it will not give you a direct solution, it will tell you what kind of design principles can be used to solve, and then you search for it and then get the solution. That is the TRIZ methodology. Okay, so 39 engineering parameters, 40 inventive principles and a contradiction matrix of 39 by 39. So this is the TRIZ methodology. I hope you understood this. So the TRIZ matrix will be, okay, these are the parameters that identified by the inventor or Altshuller. So weight of moving object, weight of stationary object, length of moving object, length of stationary object, area of moving. So like this he identified 39 parameters: force, velocity, pressure, etc. You can refer the textbook, you will see the complete listing of the parameters, and then the some explanation is given for all these. So weight of moving object is the mass of the object in a gravitational field, and weight of stationary object. So you can see what is the parameter represent, what actually the parameter represents can be seen in the textbook. So I am not going into the details of it, please read it and understand. Okay, these are the 39 parameters, and then you have 40 inventive principles. The principles are listed starting with the division and taking out, asymmetry, universality, dynamization, composite material, etc. So these 40 principles, and again they are just the principle only. So you need to find what way this principle can be used to get a solution. So for example, you can see the principle of segmentation or extraction. So it says extraction, you take out something. So if there is a design problem, see whether you can take out something and then solve the problem. So to give an example, suppose you look at the air conditioners, we had this window air conditioners. So this window air conditioner, when you switch on, there will be too much of noise coming from the air conditioner. So it is actually a problem for people who want to sleep without any disturbance. The air conditioner noise will be always there in the room when you switch on the AC. So, someone was trying to see how can you reduce the noise. So, that was a design problem. You wanted to reduce the noise. So, one way to reduce the noise is basically to reduce the compressor or improve the compressor design, so that it will not generate noise. So, that is one option. But then there can be another option like that, whichever is making noise, you take out that part and separate it. That is basically you take out, extract it. So, that is the way how actually that problem was solved. Actually the compressor which was actually creating noise, it was taken out from the window side and then it was kept separate. So, that is why we got the split air conditioner now. The split air conditioner, the compressor is given separate and the air unit is separate, and therefore, you could actually solve the problem of the noise by taking out something which actually creates the gives the problem. So, that is the principle that we will say. So, taking out is a principle that can be used to solve a design problem, but what to be taken out, how to take out, what are the other implications, that is to be decided by the designer. It simply tells you a principle that can be employed to solve the problem. So, that is the way how this principle to be used to solve the design problems. So, segmentation is divide an object into independent parts, taking out is separate an interfering part or property from an object, and anti-weight is to compensate for the weight of an object, merge it with other objects that provide lift, and like that you can actually see all these principles. I am not going through each principle. Again, you can refer to the standard textbooks, or there are a lot of online literature available on TRIZ. So, you can actually refer to some of these literature. Okay, so, finally, the contradiction matrix, as I told you, there will be a contradiction matrix. So, which inventive principle to use for solving our specific problem. Okay. So, this contradiction matrix really a 39 by 39 table or matrix, which says that the top 4 most frequently used principles in each box. So, what are the top most 4 principles that are employed by designers to solve the contradiction is listed there. So, if there is a contradiction between one parameter and another parameter, what are the most commonly used principles to solve that is listed there. You will be getting the contradiction matrix. So, you can see the contradiction here. Suppose you want to improve the weight of an object, okay, whatever, improve in the sense you want to reduce the weight of a moving object, but then you see that the area of moving object is actually going against your requirement. You do not want to reduce the area, but the area is also reducing when you try to reduce the weight. So, that is a contradiction. This is the feature you want to change in this direction, that actually going against. Now, you have to see what are the principles to be used. So, it says that principle 29, 17, 38 and 34 can be used to solve this contradiction. So, any one of these can be tried to solve it, and if you are not able to solve using these principles, it is very likely that you will not be able to solve it. Okay, weight of the moving object. So, if you want to change the force, weight of the moving object and the force. So, this you can see. Suppose you are trying to improve the weight of the moving object and force is contradicting, then you have to use this principle. But if you are trying to improve the force and the weight of the moving object is going against, then this would be the principle to be used. So, this way by looking at the matrix you will be able to find out which principle can be used to solve the problem. So, this is there in the whole matrix 39 by 39 matrix will look like this. So, this is the whole 39 by 39 matrix, just for your information, and you do not need to remember this matrix or the principle to be used. You can always refer to the standard table and then find out which principle to be used. So, I will summarize tips and then give one example how it is used in the practical scenario. So, determine the conflicts in the design, formulate conflicts in generalized parameters, determine the design principles using contradiction matrix, use the design principles to have creative solution. So, this is where actually the designer's role comes into picture, because up to here you can actually use the contradiction matrix and then find out the design principle, but then how to use the design principle and how the solution can be arrived at depends on the designer. So, creative design, then sketch the idea and refine it to integrate the product concept. So, this is the tips summary. Let us take a simple example and then we will stop here. So, you can see a iron box. So, heavy iron to remove is wrinkles are the requirement. So, you want large weight to remove the wrinkles on the iron box. but we want to have a light iron to facilitate import of human hand. So, but when you have the weight is very high, it is very difficult for the person to use it. So, these are the contradictions. You want to reduce the weight of the iron box to make it easy for use, but then when you reduce the weight, the pressure or the force applied on the cloth is reduced. So, it actually having a contradiction when you try to reduce the weight. So, the conflict is with regard to the force. So, you want to improve the force on the cloth, and then the weight of the moving object also increases. So, when you try to have more force, the more weight is needed. So, there is a conflict between these two parameters, force and moving object. Now, we will look at the table contradiction matrix and see what is the contradiction existing between 10 and 2 and what are the design principles that can be used. So, if you look at the table, you will see that the principles 8, 1, 37 and 18 can be applied to solve this problem, to directly solve this problem. Now, principle 8 is the anti-weight. So, if there is something weight, it is creating a problem, you try to provide an anti-weight, that is you merge it with other objects which can provide lift, like helium balloon or forms for reducing the weight or providing anti-weight. The another principle of 1 is basically segmentation. You try to see whether you can segment into multiple parts to reduce the weight, or thermal expansion, use thermal expansion of materials. So, you can use the thermal expansion of materials to change the weight. So, if it is tight joint together by cooling the inner part or contract heating, like this, that is a thermal expansion. And the next one is mechanical vibration. So, can you provide vibration instead of increasing the weight, same weight, if you apply vibration, you vibrate it, you can actually increase the force applied. So, that is the another method of another principle that can be used to solve this problem. So, these are the principles. Now, the designer has to see which principle can be used to solve this problem. Okay. Then finally, you will be getting a solution based on that. Okay. So, the possible solutions are, you can have a levered counterweight, you can have a foot operated iron, you can have a water spray, and you can have vibration with an eccentric weight. So, these are the potential solutions from each design principle. You will be able to get a solution. Then you decide which one you want to have. You want to have a foot operated iron, so that you will be the force can be actually be distributed, or you don't have the problem of the weight acting on the hand. Or you can have a water spray to using the heat thermal expansion principle can be used to apply the more force. So, finally, you know that the current generation iron boxes use water spray to get the required force on the surface. Without increasing the weight of the iron box, they are able to provide the necessary force for the clothes to remove the wrinkles. Okay, so that is the potential possible solution. So, this is the way how we actually get the how we use the TRIZ methodology to solve design problems. Okay, so let me there are many other examples for like this exercise aids for frequent travelers. You can refer the slides to see how the parameters can be, these design principles can be used to solve the problem. Okay, so to summarize, so we discussed about the concept generation principles, how the concept generation can be done for solving the design problem. We talked about the intuitive methods and logical methods. So, in logical method we just talked about the TRIZ or the tips, and then we talked about the mind maps and how mind maps can be used during intuitive idea generation sessions. So, with this I stop the concept generation discussion. So, as I mentioned, the ideas need to be converted to concepts, and then the design team will come up with the 10 or 15 concepts to solve a problem. The next question is, out of these 10 or 15 design concepts, which one to be chosen for making prototype and testing. So, that is basically the concept selection stage. So, we will discuss that in the next class. Thank you.